Hello, KO2 fan. Good morning. I know you're lurking, so I don't expect a response, but also hello everyone else who is also lurking. I hope you're all doing good today. Happy Tuesday. We are working on this tutorial. Data frittata. Hello. So we're working on this, like creating a tutorial, like figuring out exactly what we're going to be doing. And today I'm thinking we're going to work on the project part of it. So I actually have a list out of what this means here. So, sort of like bringing in nodes, like adding into the outline eventually. I'm thinking that eventually I'll probably write this as like an article up, along with like a series of videos, or at the very least, like just create the series of videos. Gonna be lurking, the work is still not done. I totally understand. I do the same thing all day. So thank you for saying good morning, and then happy finishing up your work. Let's see. Okay, so whiteboard on. Here's what I want to work on today is what are we going to be building? So my thought is this zombie apocalypse simulator. Basically, I was thinking of something as simple as a what's it called? A flocking simulation, but with the a key difference being that zombies instead of birds, so therefore they can eat and kill people. That's pretty much it. So let's imagine people are red-green colorblind, right? What's the colorblind rules? Is there just like a list? This isn't actually just a list. This is like telling me that I need to go look it up. Okay. Okay, red and green together can be problematic, but they can be used together sometimes. Not just red and green. Okay, so let's try red and blue then. Red and blue might be good. So you can be light blue. There we go. So, my thought is that we start the simulation with humans milling around, wandering around completely randomly. I'm thinking that the humans can bump into each other, but like can't pass through each other. So let's say we have like a very crowded space like this. So humans are moving around, bumping into each other, and then we add in a single zombie. So we turn you into, oh, red is fine. You just get it in here, we drop a zombie in. The zombie chooses a human that's like within their range, within their radius, and moves towards them. If they touch them, so if they overlap in any way whatsoever, then this human dies. So they die and they get removed. Now, the zombie keeps on moving on, and a little bit of time later, there's a chance that this zombie comes back but now, sorry, the human, comes back, but now as a zombie, and chases like the closest human that they can see, and the pattern continues. Humans don't just ignore this completely. They run away, right? So if they see a zombie, so if it's within their radius of vision, then they run away. That's a cute algo. Oh, for like what we're gonna be doing. Oh yeah, the idea of it. Yeah. So they're gonna run away, right? So they're gonna move, and they're gonna move as like directly away as they can without colliding into somebody else, right? So if somebody else is like here, and they want to run directly away, they bump in. They still like do the entire bounce off thing, and then continue if possible. This gets into an interesting thing. If the range of vision, if like one human can't see it but the other can, it'll be interesting to see like what ends up happening. My guess is that you get zombies that sort of like herd humans into the corner, sort of like this. So that means we're gonna end up having like lots of humans in the corners and the edges, and sort of like just zombies moving around, and eventually they reach a corner, and then humans are screwed, and then they get killed in mass. Now the reason for this is I want something like flocking, but with the idea of deleting. So I normally could just like take the entity and then just like have it go into a different state, but I think I want to actually have it be deleted because deleting is surprisingly expensive. And so I want to show that off. And so like deleting and inserting is like, we're contriving it a little bit. Is contrive the right word for this? We're forcing it a little bit when it doesn't need to be, but then we're gonna make it so that like a second pass on it to make it so that deleting is not actually any more expensive than not deleting, and therefore you can just do as many deletes and inserts as you want and you're fine. Okay, so what I want to do now is like figure out what are the different things that we need. Like essentially, what is the list of components that we need to handle for this? So, and then what do they look like? What does the data look like for this? So perhaps I'll go like this, and we will. Where do I want to put this? I was thinking of doing like an example inside of BBECS here. That could be interesting. One question that I have, if I create an examples folder, can I pull in other folders? Can I do uses for other code within that same sort of like folder structure? I'm really curious. So if I do examples and we do, let's just do like test.rs here. We do function main line hello world. So enter main library. These were all like examples. I don't actually need any of this. I can have like, a run function that doesn't do anything right now. That's fine. But what I really want to do I do ECS, PowerShell is fine. Do a cargo run, example, test. Oh, it is. Okay. It is 051 on this one. Oh, it was the other one that we had 06. Okay, so we get this hello world. Okay, so that's great. Now if I wanted to have like another file in here, so maybe this is like, maybe just like a helper, maybe we can have like a zombie. I guess like it would be like a zombie system. So that doesn't really work, other file .rs. And we're gonna have a pub function. I am an other function. And I'm just going to return a stir. Here, we'll return a static string. So we're just gonna return, let's not do hello world, like that. Many bangs. You are upset. Really? Okay, so now if I try to use this, if I try to mod other file, and then can I do other file? I am another function like that. Oh, okay, fine. I have to do this thing where it's like that. You're not yelling at me, but you say you need a main function. However, if I run this, look at that. Okay, so this works, but Rust Analyzer hates it. Like, just cannot stand it. And if I change you to main function here, Rust Analyzer, oh my gosh, okay. So I have to do a like result. Let's say I do like an error result with a static stir. And you have to be okay. Main has invalid return type, result, sexter, error port. Oh, okay, so you can't be an error result. Let's say we do that. Okay, so I guess I can't, wait, can I lie? Can I just say that we have this function main that doesn't do anything? But then we have like a pub function, like thing, and you return a static stir. So, hi there. So then thing is what we do here. Okay, so if I run you, oh, that works. Okay, and then if we want this to not error out for us, or not give us a warning, we can give allow dead code. And there we go, we get hi there. And if I want to turn, okay, so now this gives us examples with this. If I want to like do an example, we can do another folder. So we can do maybe like the zombie. We'll call it zombie. We'll put other file in here. In zombie, we'll create a mod.rs, and inside of mod, we'll then do a pub mod other file. So in test, we're gonna mod zombie. So this is gonna be zombie other file thing. Okay, and it still works. So this is absolutely a pattern that we can do. We can do this entire code base all in like one repository. So we can have it a library for the ECS, and then we can also have the example of, well, our zombie here, like that uses like good folder structure for how to do it. So that's cool. I like that. Now, if I wanted to have this run and you just return an I32, let's just return 32. In tests, if I wanted to pull this in, is it just use super? Something like that. Then can I also print line so what is this? This is gonna be run. Oh, use BP. Okay. Oh, okay. So I don't do that. I just use BPECS run. Okay. That seems easy enough. There it is. And then I can access that. So that's how I can access the main library. And then that's how we can do all the code. So we can definitely do this in examples. So this works just fine. Perfect. So if I wanted to, I think like just calling this zombie simulator would probably be fine. So I'm going to rename you to zombie simulator. I don't need like any of you in, I don't even need this test anymore. In the zombie simulator, I don't need this other file. The mod is going to be fine. And like the main library is going to be the actual ECS thing there. But what this means is that I can now start playing around, maybe use this as like a little bit of a documentation store. So okay, we're in mod, do this. How can I make it when I press return, it adds in the 3? There's like like auto add like comments for next line. I don't know how to tell VS Code that. Okay, well, I will just have to figure that out later. All right, so to begin with, actually, you know what? It's the easiest. I could just do this, and then later on have Rust Analyzer change this to the other system for me. So this will work out. All right, so let's start with, I can write Markdown in this. This is gonna be the documentation that loads up with docs, which is pretty awesome. Okay, so for this example, and maybe actually put this in the examples, right? I don't really need you. The folder. I need in examples. We're gonna have zombie simulator.rs. We're gonna put you in here. Okay, so what are the components that we're gonna need? A zombie. Okay, cool. Thank you so much. But I think I need a little bit more complex than that. So components aren't going to necessarily be zombies. Remember that components here are going to be the horizontals, like the actual like discrete data types that something has. So like a person here, like it can be a zombie or a person, and then they can be like we have a state, right? So we're probably gonna have like a state. So we have a state, and then no. The state can be alive, dead. So probably not alive. Well, maybe alive because it's dead, zombie, something like that. That'll be good. We have to also think about like how to query for these too. We have the queries that we created in the original version of BBECS, but I'm not super happy with that query. It's like pretty hard to use. Bitmapping is going to make that really easy, but perhaps we'll save that until like the planned sort of like make it easier change with a little bit of extra math. Okay, humans are gonna move around, right? So we need to know their location. So we're gonna have a location. That's obviously gonna be like an X and a Y. If they're gonna move around, we also need to have a velocity and probably an acceleration. So they're just constantly changing acceleration. They'll slide around a little bit. Is that okay? We may not need an acceleration. No, I think we do. I think we do need an acceleration if we're using flocking. So we need a velocity, which is also an X, also a Y. We need an acceleration, X, Y. Let's see. Do we need a size? The size should probably be the same for all of our humans. So I don't know. Even though it's the same for all the humans, it might be a good idea to have it just so that we can, well, have it. Because it is part of this, okay? So size is probably right. The size would just be the radius. So, because I'm planning on having them be circles. Let's see. We also, okay, we're gonna need the size of the arena. That should probably be a resource. So one of the ideas of using an ECS like this is we're gonna have this like world and everything goes into the world. So we say we have the world, we have components, we should also have resources. So this is going to be the arena size. And so this could be an X and a Y. All right, what else do we care about? you need to choose. We need to choose the direction that we're going as the human. So that's completely random. But we need to know, like, can we find anything? If we can find something, then we're good. So maybe we need, like, if we're our movement state almost. So that might be a system for, like, for doing that. Let's also maybe, just to help me think about this a little bit more, I'm gonna think about the like the stories. So we're gonna have we can see the world, right? So you can see the arena, I guess maybe we could call it. You can see the arena. I love that it knows that we can, like, that zombies are going to be a thing in here. Now it's suggesting zombie stuff. Okay, so we can see the arena. I then probably want to put in a single human. So a human is in the arena. So if we have a human arena, we have its location, we have its velocity and acceleration. Those are 0. They're just sitting there. They have a size. We're gonna have to have a mesh. The mesh to actually draw it out to the screen. Hi. So we have the mesh. We draw that out to the screen. That's going to be fine. Then we probably want the human to start moving around. So also thinking about this in, like, terms of systems. Good morning, Chantilly. So systems that we need to create. We need to just draw, right? We need, like, something to draw. So we need, like, just draw the entities. So if you're not familiar with ECS, like, a big thing here is that the components are going to be just, like, the raw data that makes up entities. Resources are just, like, sort of one-off that's not part of any one component, any one entity, but is still, like, necessary for us to have. And then systems are manipulations, like actions that we're going to do on the entities or on the world, basically just generally manipulations of this data. So, like, we take in the mesh and we take in the location, and we then, like, draw it to the screen. Okay, so that's great. We draw the entities out here. So, okay, they're gonna move around, right? So we have a human. Okay, we can see the arena. So you have a draw system to draw the entities. We probably need to, like, draw the arena. So that might be a, like, draw the arena system. A human is in the arena. Okay. Oh, so we need a color. So a color to, like, assign for this. Okay, so then I don't want to add the zombie yet. I want to have the humans start moving around. So humans move randomly around the arena. So we're gonna have to have a move system, right? So move humans. Now the way that works is they just sort of wander randomly. That's gonna be fine. If they're wandering randomly, we're gonna need rand. So sort of like crates that we need rand. We're gonna need some kind of like error handling crate, definitely. So they're wandering around. When they hit the edge of the arena, what do we want to have happen? Do they want them to like exit out and they appear at the top? If they do that, then we can get these check sequences, but they're never going to get stuck in a corner and then just get murdered en masse. I'm thinking that when they hit the edge of the arena, they just stop. They can't move anymore. So we need a system to like, so story is humans are stopped at the edge of the arena. So that means we need a system here for handle edges. Now, do we need any more components stuff for this? I don't think we do. Like, if we have the size of the human and the location, we know where they are. We know that they're at the edge, and then we can just stop them. Okay. So they go and do that. They're wandering around. Okay, now we have two humans in. Humans collide with each other. How does that work? I'm thinking that if they collide with each other, nothing really happens, right? We just reset their positions. In fact, maybe we don't even allow them to collide with each other. If their movement is going to collide with another human, they don't make that move. That would essentially be a move humans here. Is also going to handle not colliding into somebody else. Okay. Now we could also do standard flocking where they're constantly moving towards each other, but they're also being repelled by each other. So what if we do that? So move humans randomly. If we also have like move humans away from other humans that they are too close to. Okay. Now, if we do that, we need a state. We need not just like the state of like what they are. So this is like not necessarily a state. This is now like a type of entity, right? So we need the this entity type. We almost at this point in time also need like a move state. And so moving. Sure. No. A move state would just be like wandering right now. Because then we can have like running away, right? We have running away, we have chasing. So if they're in a, regardless what state they're in, they're moving away. They're trying to like move away from other humans. So we have the systems, move away from other humans. Do we care about them like actually just flocking where they're gonna hang out together? Or do the zombies flock? I don't know about this. Maybe the humans are attracted to other humans. So then, move humans towards other humans that they can see. Okay, well, if they can see stuff, then that means that we have to have like a sight range. So we have to have a sight range because everybody's going to have that differently, right? Humans probably have it all the same, but like zombies are going to have a different sight range than humans. Maybe they have like a much longer sight range. Maybe they have much shorter. We can toy with that. And dead elements don't have anything. Okay, so humans move randomly. Humans move away from each other if they're too close. Humans move towards each other if they're too far, or if they see each other. So, you know, protection in groups, right? Like we want to hang out together. And then also like the other flocking type thing is humans are moving towards the average direction of the group. That gives us like the real velocity, like what we see up there. So we want humans are moving. Wait. I've been doing these as stories. Hold on. Human is in the arena. Humans move randomly around the arena. Humans are attracted to each other. Humans are repelled from each other. Humans are this is going to be, they want to move in the same direction that the rest of the flock is moving. So humans are attracted to the average direction or average velocity of the group. So nearby humans. They stop at the edge of the arena and they just can't move. So that's like they, you know, that's where bad things can start happening to them. That can kill their velocity too. So, or they want to get out but they can't. That could be interesting as well. Okay, so they're all together. They then move down here. They're stuck. This is fine. They can't get out. They move all around the arena. I think that's like the rules of flocking, right? So they move randomly. They're attracted to each other. They're repelled to each other. They're attracted to the average velocity of the group. Okay. Then they stop the arena. What else? Okay. That might be just the humans then at that point in time. So now we can create. So a zombie can be created with a mouse click. So we can click somewhere to create a zombie. Now a zombie is going to move randomly if the zombie cannot see somebody. So a zombie will move. I guess the zombie will always see everything, right? Like that was like the big, I think that's the big thing in like a lot of zombie books is like the zombies will just relentlessly go after the nearest human that it can find, regardless of how far that way that is. It could be like 10 days away. It's still just slowly ambling towards that one human. So a zombie will move towards the nearest human. A zombie can't necessarily see, right? So a zombie doesn't need sight range. Okay, so a zombie will move towards the nearest human at all times. Just that's just what it's doing. I guess we should also zombies move slower than humans. What else do we want to like throw in here? When zombies touch a human, the human dies. We want to probably display the dead human for, I don't know, 30 seconds, 10 seconds, some arbitrary amount of time. So after, like, let's just say 10 seconds, the game ends. No. The dead human disappears. When the dead human is removed, there is a chance that a zombie will appear where that human is, where the human was. Okay. So then that's now, this thing is now here. Okay, so humans that see a zombie moves away from the zombie. So humans move away from zombies they can see. They still are attracted to each other, but this is just going to be another rule that gets added on, right? Like they just want out. They want away. So they're moving away. Zombies are just sort of like slowly moving towards them. Humans are moving here and sort of like bouncing around. They're all sort of moving together and just like running for the hills. Okay. What else do I want? Like, is there anything else that needs to happen? So we have a zombie. The zombie moves around. Okay. The zombie moves towards the nearest human. I guess if there's no humans left, then there's no need for the zombies just won't move anymore, right? So zombie move towards the nearest human, unless there are no more humans. Not even just in the sight range, just like these are perfect zombies. They're OP. Dota to Attitude, hello. Your talk title first draft is no longer a first draft. That sounds good. That's good, right? Also, good morning. Okay, so we can go. They get killed. They get turned into zombies. I think we're good here with stories. Is there, if any of you can think of anything, like other things we want to like put in here, let me know. Okay, we have that. Okay, so now I want to make sure that we have like the resources and components and systems set up properly. So we can see the arena. So we're gonna have the arena size. We probably also want deployments with feature flags to the cloud is the title. Oh, nice. It'll be on Twitter in no time. Awesome. So we probably want the arena color, the arena border color. Do I also want something like the arena border width for what this is going to be? Possibly. So we can easily see that. Now, this could just be the entire size of the window that we're talking about, in which case I don't need this at all. We just have the arena size. We probably want like the background color though. Okay, so we have the arena size, we have the background color. So we can see the arena, we just see the screen, right? It's like 2 p.m. in Europe, right? Probably. Well, also Europe is pretty big, right? There's a few different time zones in Europe, right? So the which part of Europe might be a good question too. A human is in the arena. Okay, so humans, we're gonna have our entity type. So we might as well just have this be human. We have a location. He gave you an evening deadline. He gave you an evening deadline, but you don't know where he is. So you don't know what evening means, your evening or his evening. Oh, that could be interesting. I actually don't know if I need this entity type because I think everything works slightly differently. And so what we can do is we can tell what type of thing it is based upon the components that it has, right? So let's look at basically entities. We're gonna have a human, we're gonna have like a dead human, and we're gonna have a zombie. So I guess like I don't necessarily need to think about this in terms of components like that. but rather for humans like this, I don't need to create like the full struct for this. With the human, we're gonna have its location, right? With location, which is gonna be like an X and a Y. The human is, let's see. So human is an arena, so we have the location. Humans move randomly around the arena. Selective duplicate. Yeah. Hello. Good morning. New game in Rust. Sort of. I'm preparing to do an ECS tutorial using everything that we've learned and like for the last several games and like experiences that we've done. Which is gonna be interesting. We're gonna I probably want to like rewrite it just a little bit for the tutorial because the BBECS it worked really well, but I don't know if I like it enough for like the tutorial level, but I think we can make it nicer. So yeah, sort of. We're gonna do a flocking simulation with a zombie human element to it as like the project for that tutorial. Oh, you don't know what ECS is? Awesome. Okay, so ECS stands for Entity Component System, and it's this entire idea of organizing your data and then having like a bunch of systems around that data. So like first data-oriented design when doing like simulations in games. And the what we looked at last time, which was essentially you're creating an in-memory database for what this is. And I'm happy to like re-explain this because every time I do, I think I get better at it, and that's going to help in this tutorial. So the idea is that we would have basically we're creating our own little in-memory Excel spreadsheet. Like think of it like that. So we have like locations, and like here's all the locations. Here's all the sizes, and then over here, this would be like human 1. This would be like human 2. This might be a zombie. And this might be like a dead human. So like something like this. And so we might say, okay, location, health, mesh. Maybe zombies don't have a health. So, well, this all exists. We have everybody has a mesh. But like dead humans and zombies don't have health, let's say. So they don't get entries in this row. So something like this. And then querying for like, we basically want to like, okay, I want to get all the humans. So I can do all of like, a bunch of just actions on all of like, I don't know, the health or like the location. The game notes are reminding you of Dark Days Ahead. I have not played, well, I can't play most horror games. I can't even watch horror movies. They scare me too much, and like I can't sleep, and it ends up being terrible. But I really like the lore and like the stories of them, so I just usually read the Wikipedia things, or just watch other people play them, but like on double speed, or like take frequent breaks. It's a roguelike 2E game. Oh, I have never played that. I might be able to play a terminal game. I have not tried a terminal horror game yet. But I also can't read like most of Stephen King's novels. They're too much for me. Dark Days Ahead. I'm gonna add that to my list I have a list over here and another. Add Dark Days. Add TUI game to list of games to play. All right, we might check that out later. I have not made a TUI game in the past. That could be pretty fun too. Oh no! Did you try to put a link to the game? Is that what happened? Is it Cataclysm? Okay, I'll keep that aside. But sorry about that. Yeah. Yeah, I don't want to put I don't want to open those right now while I'm on stream, but I'm sure I can Google for it and find it. Also, now I have that link in my in the log. So thank you, and I'm sorry that it timed you out for a second. Okay, so what were we doing here? Okay, so humans in the arena. So we have humans in arena. We have the arena size here. Humans move randomly around the arena. So if we're gonna move randomly around the arena, we're gonna have to have a velocity, which is gonna be this X and Y. And we're gonna have to have a acceleration, which is this X and Y. Okay. Now systems, we have draw the entities, draw the arena. So move humans randomly. So probably just move humans system is what we want to be able to do. Humans are attracted to each other. If they're attracted to each other, then they can see each other, right? Because they're only attracted to each other within a sight range. So they have a, I guess sight range. They're repelled from each other. Now, if they're also going to be moving around, so they have a speed. They're attracted to the average velocity of the group that they're part of. They stop at the edge of the arena. So this is all part of the move humans system, which we might need to break that system out a little bit more, but it's pretty huge right now, but we might also be able to have a lot of helper functions to help out with this. We can probably turn these into a little bit of epics. So we can also have something like setup. And here we're just gonna have we can see the arena. So that's the beginning. Then we can have maybe humans. Humans are I guess just humans. And this is all here. So humans are in the arena, they're randomly moving around, they're attracted to each other, they're repelled from each other, and they're attracted to the average velocity of the groups. That's all part of this. And they stop at the edge of the arena, so that's a combination of the arena size. We also need to know the size of the human. So this is our size, okay? So then we're gonna have zombie. So I think that's just going to be the rest of it. So a zombie can be created with a mouse click. Okay. So when we click somewhere, I guess that means in a resource we need like a clicked location. So clicked location, which will be an X and a Y. And if we think about this, this should probably be like a sum. This should probably be like an option. So like a maybe X and a Y. Because that way, if it's a none, then we don't put a zombie there. So like it happens that frame, and then as soon as we put that in there, we reset the clicked location, and we're no longer putting something down there. Okay, a zombie can be created. So we have a zombie. That means we need the location. Okay. A zombie will move towards the nearest human. So that means a zombie has a velocity, it has an acceleration, and it has a speed. It doesn't have a sight range because zombies can see everything. Welcome back, Dota. How is the article? Is it done? Okay. When a zombie touches a human, the human dies. So the idea here is that I want to delete the human, so remove the human from the arena, and we're going to put a new human in, which is going to be this dead human. Maybe a little bit forced in this example because I could just have like a state is dead. But a dead human has a location, but doesn't have an velocity and acceleration, a sight range, speed, but it does have a size. Something else that I noticed is that we need a mesh. So we need a mesh, and we need the color. Now everything's actually going to be the same, right? So actually, we don't need the mesh as part of these. We just need the color. And if everything's the same size, that's not unique to these either. So we don't need there, and that can be part of resources. So we can have like entity size. We can have entity speed is different. VR Bob G, I'm going to be creating a tutorial, but first I have to like figure out exactly how everything is going to work. Make sure I understand the project that we're going to be making fully, and then we can make it. So that's why like I'm preparing for the tutorial. That's why I'm like calling this preparing for first, before we create it. So I kind of want to do like the Bob Ross thing, which is create the tutorial project and then build the thing on like, you know, live. I am using GitHub Copilot. Yes. It's interesting how it works with Rust. It's not as bad as you might think for not having any support for Rust. Oh, it's a talk. Oh, is it a live talk or like just a recorded talk? Okay. Entity speed is different. So what was the other thing? We had the entity size. Oh, the mesh. It's like, so the mesh for an entity is the same shared across. So the things that make, entities unique, they're gonna be changed for each one, like location, velocity, acceleration. We have the sight range for you, speed, and then color. Okay, then you just have a location and color if you're dead. Zombie has location, velocity, acceleration, speed, and color, but no sight range. When humans touch, okay, when zombies touch a human, the human dies. Okay, after 10 seconds, the dead human disappears. Okay, so this is gonna be interesting. When the human is dead, we need to know how long they're gonna be dead for. So like decomposing time, alive for. It's a live talk at an XP group. Oh, nice. And I assume that XP in this case means extreme programming. So let's see. What would this be for? Like time to live, decomposing. Maybe we can just do like decomposing. Decomposition time. That could be like a number of ticks, and as soon as it reaches 0, it gets removed. When the dead human is removed, there's a chance that a zombie will appear where the human was. So this is interesting. When we remove it, is that when we decide, hey, you're infected? Or is it going to be when it actually gets removed? I don't know if it matters. It doesn't need to know that, though, at this point in time. It's that the human is dead. The human doesn't care if it's going to become a zombie. That'll be a system. When the dead, okay, so humans move away from zombies that they can see. Okay, so if they can see it, they then run for the hills. All right, so I think that's everything here. Okay, so let's update the systems now. So we have draw the entities, draw the arena. Now move humans is like pretty big, so I think we do want to like have this be like move humans towards and away from each other, right? So this is probably like multiple things. So move humans is really might need to restart Azure Data Tools is hanging quite badly. Ooh. That's not good. Okay, so move humans. So this is basically going to be like can humans see each other, and then if they can move them towards, so randomly. So move randomly. I guess this would be just different ones. So move humans randomly. Then move humans towards each other. Move humans away from each other. Move humans towards the average velocity of nearby humans. And then we want to stop humans at the edge of the arena. Then we have the zombies. Okay, so zombies, probably just like create zombie. Okay, so move zombie towards nearest human. So that's just going to be a system that does that. The zombie does move slower than humans. That's going to be fine. Okay, so this is going to be now handle zombies. I'm essentially colliding with humans, absolutely. But if we want to use the language of the domain here, it's going to be basically fighting humans. Okay. Then the human dies. So like handle zombies biting the humans die. And so now we need to remove the humans. So remove dead humans. So remove dead humans. I guess this should be handle dead humans. And then we probably also want move humans away from zombies, like that. Okay, I think that would be all of the systems. So there's probably going to be like similar things that happen inside of these. So like draw the entities. Okay, that's going to be fine. All the entities are the same, so that there's no changes in there. Draw the arena. So I think if we do like a practice run of building this, then we can determine exactly what what we need, like utility wise. But to begin with, I think this is going to work out. So a big thing about ECS is like querying, like creating this database, right? Like we want to like imagine that it actually is just fully creating the database. So how do we start like building this? I'm thinking like we're gonna try to have like lots of documentation added into this, and then I'm gonna delete all like the code part of it, and they're gonna add that back in as we do it. So it's not necessarily going to be like a live coded tutorial, but more of like, hey, here's what needs to happen, you know, let's do it. You're upset because we don't have anything. Okay, so can I convert you? No, wait. There you go. Oh, I kind of want to convert you to triple lines. like that. So it should hopefully appear in documentation for this, which I don't know. Can we get documentation showing up in docs? So if I do like function main, we just do something like that. Let's have function main in here. You are so upset. Oh, but because you're in the Astro data. Do I have that in here? Oh, okay. I should move BBECS outside of the Rust workspace. That's what I'm seeing here, because Rust Analyzer is like looking outside of what I want it to look at. It's like looking into other things, which is not good. So let's do that now. So I'm in the Rust workspace. Okay, I've saved you. I'm just gonna remove you temporarily. I think we can do is move item. I think it's recurse. And we can do BBECS. And I want to move you one down like that. Okay. Oh, maybe move item doesn't need to be recursive. That's probably copy. So ECS, do one like that. All of you get closed. Okay, everything gets closed. Everything out of the pool. I'll just do it through this. Builds. You go out there. Now we're going to add this workspace back in. Okay, maybe. Oh, okay, so you're back in here. We have our examples. So here's our zombie simulator. We have our function main. If I come into if I do a cargo doc open, this will build the documentation and then open that up again. I'm curious about whether or not like this will actually show anything. Documentation for the examples would be amazing if it was part of the Rust official documentation. If it's not, I kind of wish that they were working on it. Otherwise, I might actually want to make this a completely different project. Like a completely different repo. Because then it would show in the documentation. Oh, right. In a Rust workspace, in like an official Rust workspace, when you do cargo build, it doesn't build it in the project itself. It puts it in like the parent workspace. Oh, okay. So I think that's what that's why like then Rust Analyzer goes a little bit crazy. Because it sees everything else. Even when I don't bring those in, when I'm like CD'd into that directory, it's still going out and checking everything else. This should hopefully make it a little bit happier. Openness in developer. Okay, so here we are with BBECS. We have this like function main, but there's no... We're not... Oh, so okay. There's no way to see... Yeah. Yeah, okay. I was really hoping that we could then see the example, like the examples in here too, but I guess we don't. So because of that, I'm actually thinking that our zombie simulator should be a completely different repo, because then this can actually be real documentation that's shown as part of like the Rust documentation. So I'm gonna go ahead and copy this. Can I do brand new, create? No. Come out to here. I think we updated a Rust yesterday, so I can just do a cargo new. This can be a binary project, and this is gonna be our zombie simulator. Can add this to the workspace. And so then here can be our documentation for this. So if I save you and we now in the zombie simulator, I can do a cargo doc open. Why did you ask me to open earlier and now you just choose the wrong browser? Cool. So then here we can see, here's all this documentation that we created. This is all this stuff right here. Which is, it's just really cool that you can get this markdown support in here. Limit code, hello. But yeah, okay, this is gonna be the idea of like how to like get this going back and forth. So we're gonna want steps. I want to like add in for like the actual coding. Building a simulation, we're gonna probably want to have like steps, right? What are you? Can you tell me? It'd be nice if like I could see really easily like what level it is. I think it's a 2. Okay, so this is gonna be just basically steps. All right, so we're gonna start with like we plan this out, but we already did that. Like when we actually like build it for real. Do we want to build the world first? I think we can build the world knowing exactly what we need to build here. Because we can see this. We know we're going to bring in Rand and air on this side. We're probably going to also use air in the BBECS here. So I don't need this examples anymore. Cargo toml, we're gonna have error. I don't think we need this error because we've learned a little bit better of like what we can do with it. I don't want to use ggeze. It's like store, if possible. We're gonna find out. Like we just want error, and I think that's it for right this second. And then okay, so next topic, storing these. We have like resources, and we have the actual like components for like storing these. How do we want to do that? Previously, we used an enum. There's like good things about using enums, and there's bad things about using enums. Good things, it is really fast because it all like does memory allocation and everything else at compile time. There's no like runtime that needs to be created by Rust to handle this. However, that used like each component memory-wise had the size of the largest possible entity. So it used a lot more memory than it potentially had to. We could use dynamic dispatch, which would be faster at compile time but slower at runtime because Rust needs to create a runtime to then do the dynamic dispatching, but it would only use the memory that we really need to at that moment. I kind of like most places, most ECS systems use dynamic dispatch, and dynamic dispatch isn't that slow. We're also gonna have to have like interior mutability, so like ref and ref cell, and is it just ref and ref RC and ref cell? So we need to find out like what we need to do for this. I think let's just start like building this out a little bit. So we're gonna have probably like our entry to this is gonna be the world itself, right? So we're gonna have like hub struct world, and then inside of this we're gonna have like just all the things we need. So let's start with like resources, right? We know that we're gonna have like the arena size here. This is gonna be the simplest thing to have. So we'll have resources. And if we have resources, that's probably gonna be another resources RS. So we'll have like a resource. I don't know what we necessarily need in here, like how we're gonna store this. I don't necessarily know that this is gonna be a struct or a hash map, but I'm thinking that it'll be like, oh, it's probably resources. It'll probably like do a hash map inside of it. So we can have resources, and that's going to be resources. It's really oh, come on, find it. Just restart Rust Analyzer. Maybe that'll make it happier. There you go. Import you. Now you can find it. Now, we also know we need things like an impl for world. So like impl for the world to then like just create new. So like we want something like new, function new, world. Now this is mostly correct. I do remember, oh, there's no like next or previous. Hub function new. We're not going to take in like an initial resources. And generally speaking, in Rust, you return a self with a capital S that implements, like that implies this thing. So then we can just do self. And now we have this like resources here. We can just do let resources. Let's just create a constructor for this too. Okay, resource is new, and then we'll just store this inside. There we go. So this is upset because like, hey, this is like literally default, right? So what we can do is take this world and we can let's derive debug because people want to debug this. So if we derive this from the beginning, that's a good idea. And we're also going to default, which means that this is actually not a resources new. We can just do a self default. This means that resources needs to derive default too. So debug and default. And then that makes this happy. So if we come back down here to Zombie Simulator main, for our stories that we're setting up, which we probably want to like move a lot of this into a README file. And then we can like check off as we do the things. And then a documentation can then be more like tutorially documentation about like how things works, why we're doing stuff, and instructions for like somebody to like implement their own for it. Okay, I think that makes sense. So we have you starting out here, and we have you. We need to set you up with like that. Let's create the README. I don't know if we're going to keep this in the README. It's probably just like the plan that we're going to start with here. Oh, we don't need any of that. You just go away. There you go. Okay. I think this is going to have to be a good ending point for today. Because I have to head off to work pretty soon. But I think we're like we planned out the project. We got the essentially user stories for the simulator, and we know what we're gonna start doing. Like we know we're gonna do dynamic dispatch. So the next thing is gonna be building the tutorial project ourselves first, and like just sort of like stumble through that. Just try to like understand it. Convert it from like a complex space to a complicated space. What I mean by that is like remove any unknowns from the project that like might be in existence right now, and then turn them all into knowns. Then we can document those, and then when we do in the actual like tutorial itself, there is no unknowns. Like we've already uncovered them. we don't have to do that. We don't have to uncover them in the middle of the tutorial like I do with all of my projects that you get to see. So this is all good. I don't know if I'm gonna push this all up to GitHub yet. That might be coming up very shortly. So with that, let's go ahead and get a raid going.